Okay, so I'm going to do this one along with you, I hope. We'll see how it goes. So I want to kind of make sure that we understand what we're doing and what we're working towards. We're trying to figure out if things are proportional. And proportional means that, well, it ties into like social studies when you are trying to make a map. If something is 1 inch, um, on the map, that represents like a mile in real life. So that is a proportion. It has to stay the same and stay constant. You can't change things. Another example might be when you're cooking. If you are making a recipe and you want to triple it and it calls for 1/2 of a cup, then you need to make sure that 1/2 of a cup would be the times 3. It needs to stay proportional. And it does relate to unit rate, because what you end up doing is breaking it apart and making sure that your unit rate or your constant, the constant of proportionality, whether it's 1 to 2 or 2 to 3, stays the same all the way across. So, but 2 to 3 would be 1 to 2/3, but that's a whole nother kettle of wax. So we'll get back to that when you get older. So we're going to start with this problem. It says use the balance scale below to answer the question. Which of the following shows the relationship between the weights of one cylinder and one cube? So let's see if I can get this to write for me. So I need to look at this, and it looks like it has 1, 2, 3, 4 cylinders over here, but it only has 2 here. Okay, but it has 2 squares. So I need to start eliminating. This is what I'm going to do. So now I can eliminate this because that matches this. So by my problem solving, I can figure out that 1 square equals 2 cylinders. Now, why does that matter? Because that's essentially what you're doing when you figure out the proportionality. If I replace 1 with 2, so if I wanted to do this again, then I could put 1 cube and take off 2 more, but it has to stay the same. So says 1 cube weighs the same as 2 cylinders. We're going to click that, hit submit answer. Next problem. All right, let's see. Clear annotations. Jade's softball team went to the batting cages for practice. Jade hit 28 out of 30 pitches. If she goes back after practice for 100 more pitches, how many would you expect her to hit? Okay, so there is an independent variable. This means these pitches, they're going to keep happening no matter what. Okay, so this is our independent variable. It's not going to change. That, I've never really played a batting machine, but it keeps shooting the ball at you no matter what. So that is our independent. It does not change. So we're going to put pitches, that's terrible, to hits. So our pitches don't change. So I'm going to put I can't read it. I think it's 30. Okay. So 30 goes on the bottom. And she hit 28. So what they're saying is that that's kind of making a prediction. They're thinking there's a probability that if I go in there and I hit it 100 times, that she's going to hit so many out of 100. So there's a way to calculate this. It's where the horses numbers come from. It's where batting averages come from. It's all based on probability. Not probability. Proportionality. They take a whole bunch of data and they figure out when does it happen, and they kind of compare it. So I'm going to keep going in here. So 28 out of 30 pitches, and it's telling me 100 pitches, but it's not saying hits any except here. So this is an unknown, right? Our hit is the unknown. So I'm going to fill that in up here, and the pitches is 100. Now, we've been a little time talking about cross multiplication, so we're going to do our cross multiplication. 30 times x, again, I like to do the one with the x first on this side. So that means 30 times x equals 28 times 100. Now, if you have a calculator, you can do that. Spigen doesn't need it because it just adds some zeros. So we end up with 30x equals 2,800. Now, the last step of what we have to do is what we've been working on. I have to do the inverse of multiplication. So I'm going to divide both sides by 30. Let's see. I could probably do it in my head. I think it's 70, but I'm going to use my calculator just to make sure, because I don't want my error to be in a calculation when I have access to a calculator. So I'm doing the 2,800 divided by 30. Whoa, I'm going to check that again. 2,800. Yes, that's the correct number. Divided by 30. It still comes out as 93 1/3. That is gross. So I'm going to read to see if I'm, it says round your answer to the nearest hit. So that means whole number. That tells me that this probably expects it to be a little weird number like this. So x equals, and if I'm following their direction of whole number would be 93. So let's see here. It wants me to type it as a number, so 93 is my answer. I'm going to submit my answer. And it says it was correct. Good job. All right, so we're going to continue on. This is more like what we've been working on. During an experiment, a marine biologist recorded the length and weight, mass, of a sample of one type of fish. The measures for 4 of the fish in her sample are shown in the table below. Okay, got it. The marine biologist found that the relationship between the length and the mass of this type of fish could best be represented by a linear model. Since it's linear, that means it's proportional. A proportion has to be a line. A proportion has to be a line that goes through 0. A proportion has to be a line that goes through 0. We've heard that 3 times. I'm sure I'll have to say it a bunch more times so that we remember. All right, so based on the linear model, which of the following is the closest to the mass of a fish with 50 centimeters? This one's very tricky. So it's not giving me the data in the way that I'm used to seeing it, but it does give me length and it does give me mass. And it is asking about mass. Well, it's giving me. It's asking about mass with centimeters. Okay, so that's telling me L over M, length over mass. But I have to use this because it's not specific. I can choose any of them. I could choose 15 and 225. I could choose 20 and 295. I'm going to choose the first one just because they're at the top. So the length is 10 and the mass is 148. So the mass of a fish with 50 centimeters. So now I have to think so it doesn't trick me. Does it know the mass or does it know the length? Hope it didn't get you, but it knows the length because it says a length of 50. So 50 goes on top. My unknown is my mass and it goes on the bottom. So now we're going to cross multiply. Again, I'm putting my x first. That multiplication is on this side of the equals. 148 times 50 is on the other side of the equals. 148 times 50. I'm going to use my calculator because, again, I do not want to lose points when I have access to a calculator. 148 times 50. Whoops. Okay, let's move this out of the way. 148 times 50 equals 7,400. I'm double checking my numbers, right? Is that what it said? 7,400. Okay. So 10x equals the 148 times 50, which is 74,000. Again, Checking. Yep. All right, so now I have to divide both sides by 10. Divide by 10. My x then should equal about 740. So this is my estimation. It's not perfectly, but it's 740. So does it have that answer? Yes, it does. So we can use that answer of 740. Submit answer. Oops, I hit the wrong thing. There we go. All right. I'm going to take a pause. I want you guys to do the rest of them kind of on your own and then come back and watch the video and see how you're doing.